Okay, this is part three. We've dealt with how you're planning and the materials to use for some type of rack enclosure and storage, and then two, we talked about planning of power and understanding that if you don't plan it out, you're going to have problems. And number three is actually what are you putting in? Well, I've seen people do this where they have a small 10U rack that's got 10, maybe 11 notebooks side by side on edge that they use for clustering. And they're very commonly used to accomplish some poor man versions of low yield cluster groups or HCP style clusterings for like university or college projects and so on. Others want to design hard drive storage capacity and deal with a high speed infrastructure network. And of course, the ever loving server motherboard footprint. But to do that, you have to plan out your placement. This motherboard system here was completely gutted, and there's nothing in it from the original system. It's a completely different system now, and the panels I even cut it all out as well and put new paneling in so that it can do exactly what I need it to do. And then at that point in stage, I built this server from the ground up. This is an Isilon platform that is basically a storage array of 12 disks. Unfortunately, I'm not going to be able to open it here with one hand. And that is also a rebuild that got around some of the EMC limitations that Isilon put in play when they built the design of this. But by doing that, I have a much more faster 10 copper gigabit architecture NAS device. And of course, here we have a repurchased Google T3 appliance search engine that's actually an OEM version of the Dell 720DX. I did a video on this guy, gutted it completely, put a brand new platform environment on it. I got 24 2.5-inch discs I can utilize, and so on and so on. So the key thing here is if you look at this rack, you notice that the rack has actually been designed. So with that being said, the concept of the design itself was geared toward power and distribution, but also about heat dissipation and heat flow. So you got to think about heat, because when you throttle a CPU, it's because it's too hot. And you can do what's called high ratio density packing, but you have to design the rack and everything behind it to accomplish that. And the lowest of your compacted format is exposed for airflow, and you do not expose the top. You do heat transfer to the top so that you can get the heat to travel up through the back to the ceiling, which in turn your HVAC will suck the air down and reprocess that hot air into cool air. This design is different than this one. So you got to think about heat. You have to think about placement. You have to think about your cable management. And after all, you want to think about your purpose. Don't do any of this until you've done all that on paper. And then, you might have very special situations, like you might have a blade chassis like this RLX Series 1800, which is filled full of blade servers. He runs pretty hot, so I've got him down on the bottom. And of course, my old compact server, which I don't use anymore, but I keep it around for nostalgic purposes. I use it as a cold point, and you can do this with any form of a metal chassis, especially an empty server chassis. You can put them at the bottom to first give weight to the rack enclosure, and two, to create what we call a natural cold point, because everything is sitting on top of that chassis. It's getting cold air in, and of course in the front as well, flowing it up and out. The higher you go, notice the lower the heat creation exists. And this is a low energy Xeon based deployment. Of course, my switches run cooler, and as you go farther up, you'll see the Nortel 10 gig and so on. So you have to think it out. My best recommendation for you is to get a piece of paper. Take that paper out and do the adding up of all your wattage on your system. Look at your power supplies. Look at them get an idea of what they have, find their ratings, write it down on a piece of paper. Then go to your wall sockets. Look at them. Are they 15 amp sockets? That means they don't have the little T right there. That little T shape on the side of the receptacle socket, if you can see it real close. This is a 20 amp socket. A straight normal receptacle would be a 15 amp socket. When you do your math, you're probably going to find out you don't have enough power to do what you want to do. So as you can see here, I added more power. Not that you need to add 4 more sets of 20 amp circuits. This is a pretty heavy load. But I did that to spread the voltage across so it would never get hot. The wires would stay cool. I distribute power between all of those receptacles on these racks. Basically, one PDU plugs into one receptacle on each side of the rack, and I do it for both of them, so that's 4. And they will load balance the electrical current for what I want. Lastly, that enclosure that you want to look at, there's some really great cheap solutions out there that what are called rack rail kits, 2 points and 4 points. 2 points are doable, but they're a little bit weird in regards to managing. So I kind of like the 4-point rails. That's basically 2 in the back, 2 in the front, stabilizer rods, a bottom and a top. And it's a 19-inch rack. It's standardized. Try to get the number ID rack opposed to the non-number ID rack. It is a lot easier to work with when you don't have to deal with that. So I bring that up because I think it's valuable information for you. But this pretty much concludes this introduction to how you start working with building something like a lab for your personal use. This can be done for HPC clustering. That can be done for Raspberries. It can be done for laptops. It can be done with PCs. It can be done with 1U sets. It can be done with 2Us, 4Us, and so on. You basically well-rounded capacity. So that's it for this. I hope you guys enjoy this. I do this to help people who don't have the funds and the abilities to learn from the professionals, because I think everybody needs to be enabled to be able to be better and to keep going, because this is a good direction to go. It will give you a future, and I hope everything goes good with you for the week. God bless, and see you later.